Hello everyone and welcome to the Matlax Mathematics Made Simpler, and in this video we'll be looking at arithmetic progression or linear sequence. Let's begin. A sequence is called an arithmetic progression if there is a common difference between consecutive terms. Now let's consider the sequence 3, 5, 7 and 9. We can notice that as we move from 3 to 5 and from 5 to 7, there is a constant difference of 2 between the consecutive terms, and thus the sequence of 3, 5, 7 and 9 is an arithmetic progression, or better still, a linear sequence. Now the first term of an AP, that is arithmetic progression, is denoted by the letter A, and the common difference is denoted by the letter D. Hence from here A is 3 and D is 2. What more? Now let's consider the sequence 5, 8, 11, 14 and so on. The end term of the sequence is denoted by UN, and hence U1 is 5, U2 is 8, U3 is 11 and so on. Now the general form of a linear sequence with first term A and common difference D is given by this, that is A plus D, A plus 2D and A plus 3D. Hence we want to know a form that will be able to use to derive the value of the nth term of an AP. Hence the nth term is given by UN to be equal to the first term plus bracket into bracket n minus 1 multiplying D, where n is the term that we are looking for. Let's see how we can apply this. Now we are to find the 98th term of the sequence minus 1, minus 3, minus 5 and so on. Hence we write what we are given, that is A to be minus 1, D to be minus 2 and N to be 98 as shown here. This is minus 1. There is a constant difference of minus 2 between consecutive terms. We state the formula for the nth term of an AP, then we make necessary substitutions into the formula, then we see that the 98th term of this sequence is minus 195. Let's move on to the next question. An AP with common difference of 5 and seed term of 40 has its first term A to be what? So we write what we are given, that is n to be equal to 6. The seed term is 6. So now the seed term is 40, but the term is 6, n is 6. So then the difference is 5. Now we'll make a subject of the formula here, then we make necessary substitutions and we arrive that A, that's the first term, is equal to 15. Let's look at our last example. The fifth and 10th terms of an AP are minus 12 and minus 27 respectively. Now we have to find the first term and common difference of the sequence. What do we do? Now we know that from the general form we can substitute values in. So the fifth term is minus 12 and it's equal to A, which we don't know, plus now here 5 minus 1 gives 4 multiplying D, so 4D. That's our equation 1. Now same method of substitutions and simplifying can be applied to the 10th term, and we will get minus 27 to be equal to A plus 9D, which will be our equation 2. Now we are to solve these two equations simultaneously so that we will know the values of A and D, and now A is 0 and D is minus 3. Simple as ABC. Let's move on to the sum of an arithmetic progression. Now in general, the sum of the first n terms of the sequence U1 plus U2 plus U3 plus goes on to adding the last member, that is UN, and it's denoted by Sn. Now Now the sum of the first n terms of the AP is given by this formula, that is Sn is equal to n over 2 multiplying a bracket of 2 times the first term plus n minus 1 multiplying the common difference d. Now the average of the first n terms of a linear sequence is given by this, that is an to be equal to half multiplying a bracket of a plus l, where l is the last term. Now let's see a worked example so that we are applying what we have learned here. Now we have to find the sum of the first 20 terms of the sequence. So we know that the first term a is minus 9, the common difference d is 5, and n, that is the number of terms, is 20. So we state our formula, then we substitute values into the formula, then we see that, or we get our answer to be 770, meaning that the sum of the first 20 terms of the sequence is 770. Now let's find the sum of all integers between 8 and 90. Supposing you walk into a math exam room and you are presented with this question: is this now the time to know the number of terms between 8 and 90? No. Now the number of terms between, or the set of the terms, is 9 moving on, and it will end at 89. So now we have to know the term that 89 represents, because we don't have time to write from 9 through to 89. So we apply the formula for the nth term of the sequence. Now from here we can make substitutions into this formula so that we'll be able to determine the value of n, that is the term that 89 is. Now we will know that 89 is the 81st term, hence between 8 and 90 there are 81 integers. Now we substitute this 81 or this n and other values that we've stated earlier into the formula for the sum of the first n terms of an AP. Now we get this, then we get our final answer to be 3969, meaning that if you add from 9 through to 89, you are to get 3969. Now I guess from solving this, it's been interesting. You would like to try your hands on more questions, and these are some questions for you. Now that's all for this video, and that's all for arithmetic progressions. Now the next video will be on geometric progression, so stay tuned and subscribe to the channel. Now don't forget that this is the Math Mathematics made simpler.